Let's say we have the function f of x equals 2x cubed minus 3x squared minus 1. When we look at the graph of this function, we see that the function has a 0 between 0 and 2. But what if we don't have the graph? How do we know if there exists a 0 in the interval 0, 2? That's pretty simple. When we plug in 0 into the function, we get, let's see, 2 times 0 cubed minus 3 times 0 squared minus 1. 0 cubed is 0 times 2 is 0. 0 squared is 0 times 3 is 0. What's left over is negative 1. So when we plug in 0 for x, we get negative 1. Let's plug in 2 and see what we get. F of 2 equals 2 times 2 cubed minus 3 times 2 squared minus 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 times 2 is 4, times negative 3 is negative 12. 16 minus 12 is 4, minus 1 is 3. So f of 2 equals 3. We see that f of 0 and f of 2 have different signs. This means that the point 0, f of 0 lies below the x-axis, and that the point 2, f of 2 lies above the x-axis. So the continuous graph of the polynomial function f must cross the x-axis at least once. Keep in mind that this only works if we have a continuous graph like in this example. So in general we can say if f of a and f of b have opposite signs, then there is at least one value of c between a and b for which f of c equals 0. Let's look at the next example and find out if the graph of the function g of x equals 2x to the fourth minus 3x squared plus x minus 1 crosses the x-axis in the interval 1, 2. Again, what we are going to do is to plug in 1 and 2 into the function respectively and see if the sign of g of 1 and g of 2 are different. So let's plug in 1 first. 2 times 1 to the fourth minus 3 times 1 squared plus 1 minus 1. 1 to the fourth is 1 times 2 is 2. 1 squared is 1 times negative 3 is negative 3. And 1 and negative 1 cancel each other out. 2 minus 3 equals negative 1. So g of 1 equals negative 1. Let's plug in 2. 2 times 2 to the fourth minus 3 times 2 squared plus 2 minus 1. 2 times 2 is 2, times 2 is 8, times 2 is 16, times 2 is 32. 2 squared is 4, times negative 3 is negative 12. 2 minus 1 is 1. 32 minus 12 is 20, plus 1 is 21. So g of 2 equals 21. So the point 1, negative 1 lies below the x-axis because we have a negative 1. And the point 2, 21 lies above the x-axis because we have a positive 21. So the continuous graph of the polynomial function g must cross the x-axis at least once. By the way, this idea is based on the Intermediate Value Theorem, which tells us about the existence of real zeros. The important thing is that this only works for continuous graphs and that it does not find the zeros. It only states if there is at least one zero in the interval or if there is no zero in the interval. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.